Hello everyone, welcome to another kinetic tutoring episode, and today we're going to be talking about center of mass. Now, let's get into this problem. The prompt reads, a child is trying to stack two uniform wooden blocks 12 centimeters in length so they will protrude as much as possible over the edge of a table without tipping over as shown in the figure. What is the maximum possible overhang distance D? Now, what you want to do in order to solve this problem is you want to work your way down, starting from this top block here. So what I mean by this is that you want to see how far this top block can hang off the bottom block, and then see how far the entire system can hang off the edge. So intuitively, when we just think about this problem, we'd assume that the top block can hang off halfway. And if you thought this intuitively, you would be correct. And the reasoning behind this is, since the block has linear density, the center of mass is going to be right here at the bottom. And that's where gravity is going to be applied. And if you draw a line going down, you'll see that it falls on the edge of the block and not this open area here. So it's not going to be accelerating downwards. So at the halfway point, that's going to be a distance of 6 centimeters from here to here. And so now we have to find the center of mass of this entire system in order to see how far it can hang off this. So let's do that by considering these two as 2 points. So the center of mass of this block is going to be here. Here is a distance of 0 centimeters, here's going to be 12, and at the end we're going to have a distance of 18 centimeters. The center of mass of this block is at 6, and the center of mass of this block is at 12. They both have a mass m, so we'll have 6 times its mass plus 12 times its mass, all over the entire mass of the two blocks combined, which is going to give us 2m, and that gives us an answer of 9 centimeters, which is going to be the center of mass of this entire system, which makes sense because since these two blocks have the same mass, the center of mass is going to be right here in between these 2 points, meaning that the two blocks can hang off a distance of 9 centimeters off the edge. So there's the answer for this question. Now you might be wondering what you would do if you're given a more difficult problem where maybe the blocks aren't the same mass or the same length. So let's go over that really quickly. It's the same concept, but it's just slightly more complicated. Alright. So let's draw a block down here. Let's say it has a length of 3 meters and a mass of 2. And then we have a block on top of it that has a length of 5 meters and a mass of 3 kilograms. Now, in order to solve this, we're obviously going to want to find the center of the first one, which is going to be at 2.5 meters. So this is going to be hanging off 2.5 meters off this block. So let's draw that really quickly. Here we have this. And here's the other block. And since it's 3 meters long, it's going to be a little bit more out this way. And now let's find the center of mass of the entire system. We have this here and this here. So the entire length is going to be 1/2 here plus 5. So that'll give us 5.5 meters. So this point here would be 0, this point would be 5.5. Right here we have a distance of 1.5, so this block, its center of mass is going to be 1.5, so we'll do 1.5 times its mass, which is 2, and then plus the other center of mass, which is going to be at 2.5 plus 5, which is 3 times its mass, which is 3, which will give, and we're going to divide that by the two masses combined, which will give us 5. 1.5 times 2 is 3. 3 times 3 is 12. So our center of mass is going to be at 12 fifths, which you can also write as 2.4 meters. So this entire block can hang 2 meters off the edge. This entire system, rather, can hang 2 meters off the edge. And that's how you would solve that problem. And yeah, that's pretty much all I have for you guys. Leave any comments or questions down below, and make sure to subscribe for more physics tutorials. And I'll see you guys next time.